Yeah, hi everyone. Am I audible to all of you guys? Good evening. Yeah, hi. Okay, guys, I think I'm audible. I'm audible to all of you guys. Thanks for the confirmation. Yeah, long time, but thanks for you again. Yeah, extremely sorry for that because recently I was shifting my home to our new home. So because of that, actually, I couldn't able to continue with the session. Now everything is set because my setup was not ready, so that's why there was some delayed, guys. Okay, I'm extremely sorry for that. Oh yeah, because I am using the complete system and without the setup actually it's difficult for me to take the session, so that's why I was waiting for the setup. Okay, just complete all the setup. Now again we'll be continuing with the live. Okay, and we'll try to complete each and everything. So deep learning का live session कीजिए. So definitely I will keep that in my mind. Maybe I will also come up with a deep learning live series, okay, for you. So welcome guys of our computer vision for developer playlist, and today is day 16 and we are continuing with our discussion regarding the object detection. So first of all, we are understanding the theoretical concept of object detections. Then I'm going to start the practical implementation of object detection as well. Okay. So I think you guys, you remember in our previous session I covered this one, RCNN. Okay, explanation of RCNN. I already told you about the RCNN, how RCNN works, what was the, let's say, concept inside RCNN, why people actually started exploring any other architecture. Like today we'll be exploring like fast RCNN and faster RCNN, right? And why RCNN got deprecated, because it's like very slow, because it proposes something called region, it uses something called selective search. Okay, and it use lots of reason proposals, around 2000 reason proposals it usually apply. Then each of the reason proposal you have to give to the convolutional neural network, so it's like very time taking task. That's why today we'll be exploring two different architectures called fast RCNN and faster RCNN. Okay, so fast RCNN is also got deprecated because faster RCNN better than fast RCNN. That's why people are not using that. Instead of that, you have to use something called faster RCNN. Okay, and with respect to the faster RCNN, there are some variant of the model came nowadays. So I'll show you how we can use the faster RCNN with the help of detect on true. Then I will move to the YOLO part. So one small request, one recall of object detection. One recall of object detection. I didn't get your question. Real to animation world. Okay, so if you're joining for the first time, guys, we have already covered till date 15, so try to go through all the sessions. Definitely you'll be enjoying a lot because I have covered each and everything you need. And today let's explore the fast RCNN and faster RCNN. Okay, theoretically. So for this, again, I prepared one amazing presentation, guys, for you. So with the help of this particular presentation, we'll try to understand the fast RCNN and the faster RCNN. Okay, yeah. So guys, there is a quick recap I want to give. So I think you remember, guys, I was talking about the RCNN. Okay, so what I was using in the RCNN, let's say this is my image, and here we are using actually different region proposals. Okay, region proposals. That means we are using something called selective search, and these are the boxes we used to propose there. Around 2000 boxes, guys, we used to propose. I think you remember. If you haven't checked it out, guys, that session, please try to check out there, because I'm not going to explain everything from scratch. Okay, now I think remember, guys, I was talking about 2000 region image we used to take from the image, and each of the image dimension is 2 to 4 across 2 to 4. Okay, and these images we used to pass to the CNN architecture. So what is the task of the CNN? It will extract the features from the images. It will extract from all the 2000 images. Okay, and the execution time, guys, this particular architecture will take, it's like very huge, because at the end it has to process all the 20,000 2000 images. Okay, and just try to consider if you are passing 2000 images in a single CNN architecture, or what would be the processing power and how much time actually it will take. Okay, so that's why we are not going to use the RCNN. although this was the first, let's say, idea regarding the object detection, but later on people got some other idea, people got some other efficient idea, and they proposed that as well. Okay, that's why we are not going to use the RCNN. Then I think, remember, there I was using two kinds of, let's say, layer. One is the classification layer, one is the bounding box layer. So classification layer will try to classify what kinds of object present inside the image, and this bounding box classifier will try to, bounding box register will try to identify the coordinate point of the bounding box. Okay, I think, remember, it has to propose the region proposal, this bounding box. Okay, and we have to adjust the size as well, like width, height, and this one width, height, width, and this one height, yeah, so height and width only. That means x1, x2, and y1, y2. Okay, this one we have to adjust with the help of this bounding box regressor. So this part I already clarified, guys. Okay, yeah. Now, what is the concept of fast RCNN, guys? Okay, what is the concept of fast RCNN? Let's try to understand. Now, if you see both of the architecture, guys, so in our RCNN architecture, first of all, we applied something called region proposal. Okay, and we got 2000 actually region images. Okay, then we are passing this 2000 region images to the CNN architecture. But in fast RCNN, instead of applying the region proposal, guys, we pass the raw images to the backbone CNN. That means the convolutional neural network. And what is the task of the convolutional neural network? It will extract the features. Okay, it will extract the different features, and it will be getting something called feature map. Okay, and from the feature map itself, we'll be applying something called selective search. That means the same selective search we are using for the RCNN, will be also applying the same selective search on the feature map. Okay, image features, and it will again propose some bounding box. Okay, and it won't be propose actually 2000 bounding box. Instead of that, it will propose some few bounding box. Okay, now once I propose the bounding box, guys, what will happen? It will get different it will give me different crop and wrap processed regions. Okay, that means here also you can see, let's say, after applying this region proposal, it will apply the bounding box, and whatever object you have present inside the bounding box, it will give you as an image. Okay, it will give you as an input. So the same thing we are doing, but only the difference is, first of all, we are applying the convolutional neural network. That means the raw images, where the input images were passing to the convolutional neural network, and it is extracting the features. Okay, image features, and on top of the image features, we are applying the selective search. That means we are proposing the bounding box, and this bounding box is giving me the features. Okay, different crop features, and this crop features, guys, we are passing to another convolutional neural network called par region CNN. Okay, par region CNN, and again we are having two kinds of layer. One is the classification layer, one is the bounding box layer. Okay, that means this part is same, only the change is there, guys. Okay, we are initially applying the CNN architecture, we are getting the feature map, we are applying the selective search, we are proposing some bounding box. This bounding box is giving you some let's say output, that means cropped image output, and we are passing that to the par region CNN. Okay, and we are doing the classification, what kinds of object it is, and we are also adjusting the box size. Okay, this is the things we are doing in the fast RCNN. Got it? Now, why it is fast than your RCNN? Because here we are only doing the one-time convolution. Okay, we are only doing the one-time convolution. That means here only we are having one images. Okay, one images. But in the RCNN, you are having 2000 actually images. Okay, 2000 images you have to do for the convolution. But here you only have one images. That's why one time it will be do the convolution operations. Okay, so that's why it is faster than your first of RCNN. I hope you got it right. Yeah. And in this fast RCNN, there is another section they have added. The section name is, let me show you. The section name is this one, ROI pooling. Okay, so what is ROI pooling? We'll try to understand, but before that, let me show you one thing. So let's say this is our architecture. Okay, and you can see here we are having backbone CNN and par region CNN. Okay, now let's try to understand how this architecture is coming. So for this, they are using something called ResNet 18 architecture. Okay, you can see this is the ResNet 18 architecture, or any kinds of other actually CNN architecture they are using, and it is dividing into two parts. Okay, so let's say this is my complete architecture. You can see. Okay, and how many layers we are having? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 20. Okay, so here we are having actually 23 I think layer. Now it is dividing into two parts. Okay, now in the first part, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Okay, so 15 layer they're using for the backbone. Okay, 15 layer they're using for the backbone. That means this particular CNN, and the per region, that means this neural network. Okay, you can see this CNN, it is using 1 2 3 4 5, sorry, 1 2 3 4 5 6. Okay, 7. So 7 layer it is using for per region CNN. Okay, so single image one time, so that's why faster than 2K above images. What about that? 2K above images, that means, see, this is the 2K images you are doing the convolution operations. Okay, here in the RCNN network, but in fast RCNN you're only doing one time convolution. That means you are having a single image. Then after that you are getting a feature map. Okay, and on top of feature map you are again performing selective search. Okay, and again it is proposing some region. That means it is proposing some bounding box, but it is not proposing 2000 bounding box, Ranji. Okay, it is not proposing 2000 bounding box like your RCNN was proposing that time. Okay, there are some few bounding box they are proposing. Got it? So that's why it is faster than your RCNN. I hope you got it right now. Okay, yeah. So that's how, guys, they have divided this architecture in two parts. One is they are using for the backbone. Okay, backbone CNN. Another part is they're using for the per region CNN. Okay, and after that, let's try to understand the new, let's say, layer they're using called ROI pooling. Okay, so you can see how to make this part is a differentiable, because at the end only the difference is they're using very fast time the CNN architecture, then they're getting the feature map, then they're applying the selective search. Okay, and whatever results they're getting from the selective search, they're doing the cropping operations. Okay, but here instead of cropping, directly cropping, they're using something called ROI pooling. Okay, so after getting the cropping, they are passing to the ROI pooling. Now let's try to understand what is the ROI pooling. And after ROI pooling, they are passing into the per region CNN. Okay, so let's try to understand about the ROI pooling. What is the ROI pooling means and how it works. RCNN lots of images eligible or not? Eligible or not? RCNN lot of images eligible or not? Lots of image means what you want to say? Yeah. So here you can see, guys, this is the definition of ROI pooling. ROI max pooling works by divide the H time W ROI window into capital H times W grid of sub window of approximate size H divided by capital H times W divided by capital W. Okay, so this is the definition of ROI pooling. Let's say here we are having an image matrix. Okay, so here we are having an image matrix. Now what is the definition of ROI pooling? So ROI pooling means, first of all, it will check the height and width of the this particular window. Okay, so this, let's say here I'm only taking a window, so this window size is 1 2 3 1 2 3 4 1 2 3 4 5. So height is 4 and width is 5. Okay, so this is the window we are using on top of the image. Okay, that means just try to consider, let's say here you are having different bounding box, right? So one of the bounding box will have another dimension, other bounding box will have another dimension. Okay, so that's how it might be different dimensions. So let's say as of now, this is the dimension we got. So this is the height and this is the width. Now what we have to do, we have to make it half. Okay, how to make it half? So that's how we can make it halves. Now H, capital H would be 2 and capital W would be 2. So let's say this is 5, but we are only taking the 2. Okay, so now what will happen, guys? Now it will make a half line here, you can see. So this is the full window. Now H is equal to 2, that means height is 2, 1 2 1 2, that means it will make a half line here. And for the W also, that means for the width also I have to make it half. Now how I can make, let's say 1 2, I can make it here, either I can make it here 1 2. Okay, both places you can like make it. So see, I have made like that 1 2. So this is my half, this is my half part. because here you are having an odd number. Either you can take this side, either you can take this side. Okay. Yeah. So this particular part you will be getting. This part you will be getting. Now what you have to do, guys, you have to apply the max pooling. I think you know what is max pooling. It will be taking the maximum number, guys. It will be taking the maximum number. Let's say this is my, so see, this was, I was making half here, but in this example I was making half here. Okay, that means from right side, but here I am taking it from the left side. Okay, so if you're taking from the right side, so here you can see the maximum number is 60, and here the maximum number is 91, here the maximum number is 96, here the maximum number is 85. So this is called max pooling, guys. So that's how you take the max pooled number. Now can anybody tell me why we are taking the max pooling number? Why? I already talked about that in my CNN foundation, guys. Remember? So here I'm capturing some more meaningful informations. Okay, here I'm trying to capture the more meaningful informations with the help of this max pooling. Got it? Yeah. Got it? So you can see, and then max pooling the values in each sub window into the corresponding output grid cell. Got it? So this is called ROI pooling. That means in this part, the cropping you was image you are getting, na? So here the cropping image you are getting. So you are passing it to the ROI pooling, and what the ROI pooling is doing, it is trying to capture the more meaningful informations with the help of this max pooling. Got it? Yeah. Then it is trying to pass to the power region CNN. Yeah. And you are doing the classification, what kinds of object it is, and you are also adjusting the bounding box size the way you did for the RCNN as well. Okay, there is no change here. Now let's try to understand how to train our model. So they already proposed in the paper, initiating from pre-trained networks. That means you have to take the pre-trained networks. We experimented with 3 pre-trained ImageNet networks, each with 5 max pooling layer, and between 5 and 3 conv layer. Okay, see the section 4.1 if you check the paper. Okay, paper of this fast RCNN. So they have mentioned our experiment used 3 pre-trained ImageNet model that are available online. Okay, the first is the CAFnet they're using. Okay, then the second one they're using something called AlexNet. So I think essentially AlexNet. See, there is another name of the AlexNet called CAFnet. Okay, you can also call it as AlexNet. You can also call it as CAFnet from RCNN. Okay, then we alternatively refers to the CAFnet as a model for a small. The second net works with VGG CNN. Okay, that means they're using something called VGG network. Okay, then the another model they're using something called VGG 16 networks. That means 3 networks I think they're using. So they already mentioned we experiment with 3 pre-trained networks. Okay, one is the AlexNet, VGG CNN, and the VGG 16. So that means this architecture I'm talking about. This architecture, the architecture I showed you, this architecture. Okay, this architecture, they're using 3 kinds of network. They experiment with 3 kinds of network. So these 3 kinds of network they are experimenting with. So let's consider this is the architecture, guys, we are using. So any of the architecture we are using here. So see, what is the change here in the architecture? What was their change? The last max pooling layer is replaced by the ROI pooling. That means here you can see here we are having the max pooling layer. The last layer we are having a max pooling layer. Okay, so this is replaced by ROI pooling. Okay, this is replaced by something called ROI pooling. Now here you can see this is the change of the ROI pooling. So they're using something called ROI pooling here with the size of 7x7. Okay, and what is the second change? Second, the neural network last fully connected layer softmax, which is where to train hundreds way ImageNet classifications, are replaced with 2 siblings layer described earlier. Okay, that means at the last layer, I think you remember, of all kinds of pre-trained CNN architecture will have 1000 units. Okay, 1000 units because they're trained with ImageNet dataset. Okay, so they have replaced with 2 kinds of network, guys, 2 kinds of fully network. One is for the softmax and then for the L1 loss. Okay, Yeah. Softmax means this is the classification. Okay, this is the classification one. It will classify what kinds of object it is, and this will give you the box, actually, let's say position. Okay, box, let's say position, or let's say box size. You can adjust the bounding box adjustment. Okay. Yeah. And the third actually change they have done, the network is modified to take two inputs data, list of the image and the list of the ROIs into those images. That means your input image and the list of the ground truth value. Now where you will be getting the ground truth value, I think you remember we perform something called data annotation. Okay, and after data annotation we get the annotated file. So this is called actually ground truth value. Minimum softmax is the activation function. This will give you the probability. Okay, probability of each class, Ranji. Okay. Hmm. So this was some modification, guys, in the architecture. So that's how, guys, they propose something called entire fast RCNN. Okay, but again there was some issue with the fast RCNN because again it was using something called selective search. So I think you remember, guys, if I show you the architecture, so still they are using selective search. Okay, selective search, and because of that they're proposing region proposal. Okay, region proposal, that means the lots of bounding boxes, and again it was passing to the per region CNN. Okay, and the computation was happening. That's why it was a little bit slower. Then they propose something called faster RCNN, which is faster than your fast RCNN. Now let's try to understand about the faster RCNN. So let me show you the faster RCNN, guys, right now. So see, as per the experiment, guys, as per the experiment and research, they got to know if you're taking any architecture with a region proposal, so this will take some time. Okay, definitely this will take some time because here we are proposing some region proposal, some bounding boxes. Okay, but without region proposal, if you're taking any architecture, this will take less time. Okay, now the first things what they did, guys, in the faster RCNN, they replaced that ROI pooling with a different layer. They replace this ROI pooling with a different layer because in the ROI pooling we use something called selective search, as we already saw that before, right? So what was the replacement? They're using something called RPN. Okay, RPN, guys. Okay, so they're using something called RPN. So here you can see initially it was a ROI pooling, so they have replaced with RPN. See, ROI pooling would be there, only the part they are changing the selective search. That means they are not proposing any kinds of region right now. They are not proposing any kinds of bounding box right now. Okay, that means in RCNN I was proposing 2000 bounding box. So here this kinds of selective search is not getting applied. So this part we are removing and we are introducing something called RPN. Full form of RPN is like I think you can search here, RPN full form in CNN. It's region proposal network. Okay, region proposal network. Now it is a different region proposal network. Okay, the region proposal we used before with the selective search, it was not like that, Ranzi. Okay, it is a different region proposal network. Let's try to understand this one. What is inside the RPN? Okay, now we'll try to understand this one. Yeah, so as of now, let's consider this is our input image. The dimension is 600 times 600. Okay, now you can ask me why 600 times 600, because if you open the faster RCNN research paper, so they told in the paper they're using the minimum image size is 600 cross 600. Okay, that's why we're considering 600 cross 600. Okay, and inside that we can see a car, and this is a labeled image. As of now, just consider this is a labeled image and this is a car. Okay, annotated as a car. Now let's try to understand what is inside of the RPN. Now before understanding the RPN, first of all you have to understand what would be the input of the architecture. So definitely the input would be the original card as well as the annotated part, that means the ground truth. That means this is the original image and this is the ground truth. Okay, we are passing because this is a supervised learning. Got it? Now after passing there is a max pooling, guys. Now what is the task of the max pooling? I think I already discussed in my convolutional neural network foundation. So this will reduce the image by half. Okay, it will reduce the image by half. Now what was the original dimension? Original dimension was 600, 600. Okay, now after applying a max pooling, it will become 300 cross 300. Okay, then again there is another max pooling, so it will become again half, that means 150. Then again max pooling, it will become again half, that means 75. Then another max pooling, again it will be half, like 37. Okay, so that's how guys your image dimension is getting decreased here, and your architecture is getting the features, it is trying to capture the features. Then this particular output will go to the RPN right now. Now what inside the RPN? So this is the another network we're using. You can see this is the convolutional neural network only, but this is the architecture 3x3, 1x1, and they're using 512 filters. They're using only 2 filters here. Okay, see, this is the architecture. Now with this architecture, they're using something called anchor box. They're using something called anchor box. Previously they were using region proposals, that means the selective search, they're proposing some bounding box, okay, 2000 bounding box, but now they're using something called anchor box. So this is how your anchor box looks like. Now what we have to do, okay, now what we have to do, reducing for use the max pooling, reducing, yeah, with the help of max pooling we reduce the size, Ranji, yes, you're right, and it will capture only the most relevant features. Okay, the max pooling, I think I showed you, it will only take the relevant features, okay, most let's say I mean occurred features it will take, that is the maximum number it will take always, right, maximum pixels. Now this anchor box we have to plot to the image. Now see, that's how we have plotted. Now this anchor box will tell whether inside the anchor box any image is getting detected or not. Okay, you can see definitely there is a image detection. Okay, now what will happen, this is not actually suitable for all kinds of size of the object, because you can see in this anchor box this image is not getting detected properly. So that's how we have to also give the different size of the anchor box. Now in this particular demo, in this particular fast RCNN architecture, how many anchor boxes they're using? They're using 9 anchor boxes, okay, with a different size. They're using only 9 anchor boxes with a different size. Okay, and every time it will move to the image, it will try to identify whether any object is there or not. If any object is there, they will classify that object, and they will also adjust the bounding box size. Okay, that means the anchor box size with a regression layer. Okay, the way we learned in the RCNN, the same thing will be happening here, only the change is they're using something called anchor box, 9 anchor box with a different size, so that it will give you the object present inside the image. So this is the idea, guys. Got it? Now see, this is the entire visualization, you can see and you can understand how things are working. Okay, so that's why it is more faster than your fast RCNN, because there we don't have any kinds of selective search, let's say, algorithm. We are not using any selective search algorithm. Okay, yeah, and this is the architecture, guys, we'll be using for the object detection task. And now if you open like this one, let's say detect on true framework, so they're having the model view. Let me show you, they're having the model view, detect on true model view. So inside that, the fast architecture, you can see the faster RCNN, okay, for object detection baseline. And it is also having some variant. Okay, this is also having some variant, like you can see R50 FPN. Okay, so this is also having some variant. You can see this is also having some variant. Okay, so that means they trained with different variant of the model. Okay, and this model is available in the model zoo. Now maybe in the next session I'll show you how we can use these are the model to perform our custom object detection with our custom data. This is the idea. Okay, but I clarified all of the, let's say, theoretical understanding how this model is working. Okay, and how we are also evaluating the model with the help of this one. I think I also talked about mean average precision, right? So this is the measurement metrics of the object detection. So each and everything I already clarified. Now from the next class onward, guys, we'll be understanding the practical implementation of that. Okay, so once we understand the practical implementation of faster RCNN, then I'll move to the next one, which is nothing but YOLO. Okay. So once object detection is cleared, object detection is done, all the theory and practical, then we'll move to the next task, which is nothing but image segmentation. Okay, so that part I will be talking about also. And for image segmentation, we'll be using something called mask RCNN network that time. And I will share all of the resources, guys, all of the PPT in your resources section. I think you know we have a GitHub, guys. Let me show you. So it is available in the description. So this is the GitHub link, and here I have already published all of the, let's say, class materials. So till day 15 everything is up to date, you can check it out. So day 16 also I'll try to update here. And if you want to read the research paper, guys, simply you can search like faster RCNN paper. So you'll be getting the paper link as well. See, this is already open source. You can open it up and you can go through the paper. Okay, we'll be getting some more understanding on that. Okay, so yes, guys, this is all about of our fast and faster RCNN. Now in the next video, that means I think tomorrow we'll have the next session. So I'll show you how we can use this faster RCNN practically with the help of Detector2 framework. Okay, and Detector2 is developed by Facebook. Okay, Facebook research team, they have developed this particular framework for object detection, image segmentation, key point detection. Okay, these are the tasks you can perform with a single framework. Okay, so you can see all kinds of models are available. This is for object detection, this is for segmentation, this is for key point detection. Yeah, so 3 kinds of tasks you can perform with a single framework. Okay. Okay, so today I'm not continuing any practical, guys, because I wanted to complete the remaining part we had. Now let's connect in the next session and I'll show you the practical implementation of it. Okay, till then, guys, you can revise all of the concept. And if you like the session, guys, please try to like and subscribe to my channel. So let's hit 50k subscriber as soon as possible. And definitely if you need anything, guys, from my end, definitely let me know. I'll try to bring in my channel. Okay, yeah. So thank you so much, guys, for joining the session. Always remember, consistency is the key. Try to learn consistently. Definitely you will be able to actually complete each and everything. Okay, thanks for watching, guys. Thank you, guys. Bye.